Okay, so things have changed, and in my opinion, to the better. And I'm here to explain just a quick little update of what have changed, what has changed, because it has been a while since we recorded anything. I had some problems with my internet yesterday, so streaming it didn't go very well, and we also didn't have the time to do it on last Saturday. Although I did touch the code, and things are now finally working. So the idea for today is for me to go sort of like in a monologue here and try to explain a little bit of what has changed. So first things first, the bug that we had before, in which the pieces would glue to the board when they spawn, and that was making it very hard to debug any sort of feature that we wanted to implement. That was fixed, and what was the problem is kind of hard to tell, although I believe the main problem was in the has collision function. As far as I remember, this was not as it is right now, especially this bottom part. So we would have to check it out the last recording to know exactly the differences, but that doesn't. I don't think that matters as much. Because the whole code was refactored in such a way that made it a lot easier for anybody to read, at least in my opinion. So let's start with the main game loop then. So the main game loop now it is just this. So if you compare this to the previous version, this is a lot better because if you need to tinker like a specific aspect of what the main game loop should do, you can just go to that function. So for instance, update state, I'm gonna shortly explain what state means now because that is a kind of like a new abstraction. But the update state is basically a function that lives in here now that actually does the interpretation of the input. So before, if you remember, or rather, if I remember correctly, what was happening is that the handler from movement was also doing the interpretation of what that input means, and I decided to separate those just for the sake of separation of concerns. Maybe that previous design would work, but it's definitely harder to manage in my opinion. So when you the move event will just update the current button with the key that you pressed on the keyboard. Um, and then the update state will use that button and call a function called handle input that will interpret that function. Not that function, sorry. It will assign a function to that input. Right. And that actually is a perfect bridge to go to what the state means. So every single function now that is related to an input, it will return a state a state. So this is kind of like a little bit similar to how we did it in Radiant, in terms of like we have a bigger game state that we keep passing it around people, and then these people, quote unquote, functions return the new game state that we're gonna use. It is not like that because we're still using slots and the entity, the shader entity or whatever. So this is still mutability all over the place, but but we are extracting from the handle input the state in like an immutable manner, right? So this is a little bit similar to that. So let's go to this function actually, because for me that's one of the highlights of this new version of the code. So previously the handle input function was the attempt to move function, but I decided during my refactoring that the design was so great, like the versatility and the readability of it was so great that I decided to upgrade it to handle all sorts of inputs, not only movements. But it is definitely still using the same code from attempt to move was using. So in terms of movements to like move to the left, to the right, rotation, etc., it's still kind of the same. I just changed some key presses. Now to the rotation you press Q and E instead of W because W does a different functionality now. and I'm gonna explain these functionalities later. But the main point here is what I said before, which is now that we have states, right? We have like symbols that represent states. So we have a pause state, we have an idle state, we have no collision state, bottom collision, board collision, and so on. So for instance, the move adjustments function calls the has collision function. This was already happening before in the previous version of the code, but the has collision function now returns one out of four possible states. So there is a plane here. Maybe that was audible. I'm sorry for that. Okay, so the four possible states. I'm gonna wait for this plane to go. Okay, it's finally out. So we have four possible states, and the has collision now will start assuming that there is no collision, and then we're gonna decide based on some and the same functionality as before. But remember, I believe this block is changed from the previous recording. We're gonna return a side collision, a bottom collision, and a board collision. And the main reason that we wanted to do this before was because we want to handle events using the game engine library, which is trial. We still didn't do that yet. I don't know if you're gonna do that in this version, to be honest. But this sort of like separating the type of collision was very helpful. And I also introduced two other states, actually three new states, aside from collision related states, which is the idle state, the pause state, and the nil, right? So if you have a nil, that means that the game is over, the game is done. If you have an idle state, that means that you are not pressing any keys, so the piece is just gonna fall down naturally. And you have the pause state, which means that you press the P on the keyboard, and then you're gonna flip flop between paused and then unpaused, and so on and so forth. So I actually want to go through some of the functions in this file because I think they are very important. Because before this was being done all in the main game loop, and now I separated them, and it's much easier, in my opinion, to read. So, for instance, I already explained the update state, right? So the update state is the function that actually communicates, does the interfacing between the inputs that the user pressed and the functionality that we're going to do about it, right? And why this matters? Because if you take a look on the main game loop, we allow you to communicate with the game, but that that will update the state slot inside the game, and depending on it, we're gonna do more or less stuff. So this is important because this means that if you, for instance, the game is done and you want to restart the game, this needs to be available as an option for you to press a key related to restarting the game. Because otherwise, once the game is done, you will never be able to restart it. You have to close it and open again. So this was very nice because of that. So handle score level is basically the same functionality of like leveling up and getting score, doing like playing the game normally, but now this is separately. I think this was already a function before. I just changed the name. So um, let's follow the main game loop thing here. So like I said, this is for managing score. Here we are drawing the board. I'm gonna go shortly explain what drawing means now. And then we have that the same if, not the same if, but exactly the same, but kind of like similar if to what we had before. But before we also checking if the current button was down, and I believe this was related to the automatic falling functionality. But in this new version, there is not necessary anymore, and it was a lot confusing because every time nobody remembered why the heck we needed that condition. So if you have a no collision state, well, let's actually do the opposite. So let's suppose that you had a no collision, right? That means that your input worked, so it will ask to go left, and that was already done because again, mutability, we are doing that in a mutation manner. But that means that you also need to fall down because again, regardless of the input that you press, even if you don't press anything, the piece will fall down. So let's actually go to the handle automatic fall. So what this does is very, very simple. It's just going to call exactly the handle input function And this is the reason why I am not using the current button as a slot from the board, although I could, right? Because this has slots, and we could just do with slots inside this function use the current button. I didn't do that because I wanted to reuse this function for specifically this case in which I want to control externally which input um, I want to manage, but I don't want to do a setf on the create button before doing that. So this is basically checking what is the response asking to go down, because remember, if the piece go down, maybe you're gonna reach the bottom, maybe you're gonna have a collision with the board, and so on. So, and then we have a function called handle state, and the handle state function is basically like plumbing collision related stuff and idling, right? So if you have a bottom collision or a board collision, that means that you need to go to a next round, and a round basically means that you're gonna glue a piece to the board and instantiate a new piece. That's basically the action of going to the next round. And we also have this condition with the idle, and I believe this is because of the case in which you don't press anything, right? So there's a possibility. Well, this will never. I believe this will never go to idle, right? Well, yeah, I believe. I believe this never go to idle. Probably I'm using this function somewhere else, and that's why we need this when here. It's kind of hard to remember right now because, well, I did this on Saturday, and today is like Thursday. But anyway, that's definitely a thing. We can even try to check that out. So, is there a way that this can go like idling? Yeah, this case is definitely idling, but I want you to notice because we're gonna ask to go down, right? So we're gonna go to this case. Is it possible to has collision to return idle? No, it's not. Yeah, so I believe I added that when for a different scenario, um, which is very hard to remember right now. Handle state. Yeah. Oh, it is because of here. Okay, okay, now I remember. Because let's suppose that the state of this is not no collision, right? Maybe it is idling, and in that particular case, when you have idling, um, yeah, so that's why I did it. If you have idling, that means that you didn't press anything, because that means if you don't press anything, that means that this will not be no collision, right? This will be idling. But if you have idling, you also need to fall down. So you need to fall down in two different situations. You need to fall down once you have a non-collision precedent input, right? And you also need to fall down if you don't press anything. So the way that I did that is to call automatic fall here, and also have a way to the handle state to also call automatic fall down later, right? So it is a little bit confusing, and maybe there's a better way to do it, but that's the way I did it. The last thing that I want to mention in this file is related to the check endgame condition. So the way that we are checking the endgame, which is not the best, is basically when you notice that you're gonna do a next round, that means that the current piece is at spawn position, right? So what we do is we grab, because we know that, we ask if we have a collision, knowing that the current piece is at spawn position. Because if that's the case, that means that at spawn the pieces are already gonna glue. That there's a problem related to that, which is the fact that maybe the piece would be able to fall down, like it will not be 100% overriding the board, but would be just falling down, like immediately falling down. You know what I mean? Um, but it's very hard to. Well, we could make a function that would be similar to has collision that would detect specifically overriding, like the collision will not be only like, oh, this piece is ready to glue. No. This piece will override the board, which is actually the end game condition that we wanted. But because we don't want to have the hassle to re-implement this function right now and so on, we decided to just go like, oh, if you have a board collision when the piece is at spawn position, just say that the state is new because the game is over, basically. And I think that's pretty much it in terms of the main game loop functionality. I want to spend some time explaining the new functionality that I added to the handle input function. So the W now does a swap. So for people that don't know, some versions of Tetris actually allows you to store a piece. So if the piece that you have at the moment is not a great piece to make your game right work, you can just save it or swap it with the piece that you already saved before. So this is specific, theoretically speaking, if we want to separate classic game mode from like this older game mode, we would have to have a way to manage this sort of functionality depending on the mode that you chose. But we're not going to implement game modes in this iteration of Letris. And I'm going to explain this at the end because we kind of made like a roadmap out of it. So the next functionality that for me is super useful, that also is not present on classic Tetris, is the space. Pressing space actually calls for an insta place. And that means, what is an insta place? Is when you don't want to keep pressing down to the piece to just move down. You just it to immediately go to the touching the board, right? So this is very useful for adding speed to the game, removing sort of like the boringness of having to press down just because you're already certain of the position that you want the piece to go. We also have pausing of the game, right? And you also have resetting the game. So I'm going to go with the reset first. So resetting means that we want to we want to go to the shader entity and basically reset every single slot to their init forms. The way that we accomplish that, and this is thanks to Commander. So he talked in a I think he mentioned that he talked in a Common-Lisp Discord server and people suggested this way because there are two ways to do this. The first one is to do a with slots in here and basically do a setf with all the slots, but there are like various problems with that approach. The first one is that if you add a slot later, you're gonna have to remember to go to the handle reset function and add a new setf. And the other problem is that you're gonna have to know. Maybe there's a way that you don't have to know the init form, because I was thinking about you do a setf with a slot, and then you put like I don't know new or I don't know you put true or whatever. But you're gonna have to know that information, right? So you're gonna have to go to the definition of the board, and like going back and forth like, oh, this init form is new. Okay, so do a setf to new, and so on. And that's very annoying, and that's very and it's very inconvenient, right? Inconvenient to do, which means it sucks. So we wanted a way, that allows us to keep doing changes on the board, but the resetting would work regardless because it would automatically just work. So the suggestion that people gave Commander is to do I believe a change class, which as far as I can tell is basically casting, uh, and that will automatically use the init forms of all the possible slots. So what we did, we created a dummy shader entity, which has the same let's say signature as the board. So we change to that and then change it back to the board shader entity. So that works, right? It's not the best in terms of like what TF, it's a little bit confusing at first, but this is like 3 lines of code instead of like multiple lines, and also it's avoiding the problem of you having to remember when you change the board, you need to go here. Next is pausing. So the way that pause works, I basically check if the game is already paused, because if it is, that this is a toggle, right? So if you want to pause and unpause. So if the game is already paused, I'm gonna unpause it because this is a slot that we have within the entity, and I'm already gonna say that the button is S. I don't remember exactly the problem that this solves, but I remember that if you remove this, you're gonna have a hard time. And this needs to return again a state, right? So we're gonna return idle in the game in the particular scenario in which you are unpausing the game. And in the case that you're pausing, we're just gonna do a setf with the pause and set the game state to paused. And this is important because if you press any of the inputs, um, if you press any of the inputs, oh no, it's not here actually, but I'm gonna mention here anyway. So this if is very important, right? This if is very important. If the game is already paused, keep it paused instead of going to idle, because there is a corner case in which if you press in the case that the movement is new, right? In the case that the movement is new, this is why this otherwise is here. In the case that the movement is new, before it was always going to idling, but I noticed that if the game is paused, and then this would like unpause automatically, and that's bad. So I decided to add this if here, and that worked. We are also checking for the game being paused in this tick handler here. So this is the trick that we use in order to delay the game, right? To make it slower. And we already implemented the delay getting smaller with time, so the game gets faster as you level up. I'm going to try to go that shortly. It's already 20 minutes. I talk too much. But anyway, so we are also checking if the game is not paused here. So I believe that's it. I don't think the main game loop actually cares about that. It only cares about the game not being done, right? And just for the sake of finishing the main game loop, now that we have the abstraction of the idle state, we are fortunate enough to be able to reset the button every single time in the main game loop. So if you don't press anything, because before if you pressed and we would have saved that, and so how do we know that you stopped pressing it, right? I don't even remember how we were doing that before, but the way that we're doing now is very, very, very straightforward. We're just gonna every single time at the end of the main game loop, we will reset it for you. Whew. Okay. Last one. The last thing that I want to talk about is how we are doing the swaps and the insta places and like the whole quote unquote design philosophy around that. So as you can see, um, this is also using move adjustments. And why this is the case? Because some of these movements, such as the insta place, we want to be able to take collision into account, right? So the insta place needs to stop putting the piece automatically down as soon as it detects a collision. So that means that we want to reuse the collision, right? The collision process. So because of that, I am reusing move adjustments. So that's actually a reusability standpoint, because the move adjustment is already reusing has collision. So every single functionality that you may want that involves detecting collision, you can just call move adjustments, and you have the freedom of just choosing of swapping the function that you're gonna partial apply. So that's another thing. We are using partial application in here to do the using macros in order to be able to control from here some of the things, right? So for instance, let's go to the instaPlace functionality first. So the instaPlace, it's gonna receive a thing first, as we were doing with the change chords, right? So the change chords here, you were defining how you're gonna do a +1 in a certain coordinate or not, right? So in the insta place, we receive the board, and then we need to receive a lambda, because again, we're gonna like quote unquote partial apply. And what this is doing is really cool, because it's basically doing a loop while, and it's gonna do a thing while we don't reach a collision, right? Which is pretty cool. This car here is because this is a list, right? So that's a little bit unfortunate, but as far as I know, this is the way that I made it work with this backtick comma thing. And what the reach insta collision does is basically, again, is reusing handle input, which is really nice. And it's just asking to put the piece down. Again, not using the current button because of that, because I want to have this freedom. And if we reach the bottom or we reach the board collision, that's when we're gonna stop, right? And this is already this handle input. So if you think about it, it's like recursive function, because we start from here. You press the space, and the insta place will eventually call handle input again, and so on and so forth. And then we're gonna return. This will mutate the piece, right? So the has collision function already mutates the piece. Sorry, the move adjustments already mutates the piece. That's what I meant to say. And we are returning the mutated piece. We are returning the mutated piece. And the same applies to the swapping. Commander noticed that because the swapping always swap the piece to the spawn position. Like let's suppose that you have save the piece, and the current piece that you are manipulating now, you decided along the way that you want to swap it. When you swap it, you're gonna the swapped piece will appear on the top of the board, right, on the spawn position. So theoretically speaking, I don't think we actually need the move adjustments in this case because we're not handling collision because well, the saved piece is respawning at the spawn position. But I decided to keep it anyway. Last thing. So we discover. I want to talk about drawing, and we discover how to interpret this thing. So it was actually wrong the way that we were doing it before. I believe we were assuming that if you go up, that's increase the x, right? So it's gonna be like 3, 0 and 3, 1 and so on. But it's actually the opposite, which makes a ton more sense, right? If it's x and y. So we discover how those work. So if you go to the number to tile function that we did last time, now this is finally correct. And you may have noticed that we have a new color here, and this is because we added a border using a tile as well. And that's the final piece of the puzzle that I want to explain in the last 4 minutes. Is that we want to be able to draw a border around the board, but we don't want that to mess around with any of the logic that we did before, right? So the board that we handle all the logic is 24 by 10, but we want to do something with 26 by 12 because we want to add borders, sides, and top and bottom, right? So this actually was Nathan's initiative. So Nathan suggested to just make a function that controls the drawing and just do that on the drawing phase of it, because we are still cloning the board. And why we are doing that again? Because we need to be able to glue a piece to draw it. But this would affect the logic as well, right? Because gluing actually makes a piece part of the board. But we just want to glue it just for the sake of showing to the user the piece that is flowing on top of the board. That is still the abstraction that we are using here. So we clone it, we glue it, and then there's the extension. And what the extension does, it creates a new board with the new dimensions. It fulfills this new board with the contents of the previous board, but adjusting to keep the borders empty, right? So this is where the plus ones are coming to place. And then we have a draw border, which is going throughout the sides, the top and the bottom borders, and it's filling its value with the number 8. Why? Because the number 8 is the tile black, right? Number 8 is the tile black. So in this sort of manner, board to tile map actually is exactly the same that we did before, because we're not messing around to this, right? So as you can see, board to tile map, instead of receiving board clone, it's going to receive the output of extend board. And in this way, it's really, really nice, because then we don't have to change. Board to tile map doesn't care about what is the size of the board, if it has border or not, it doesn't matter. It's always going to work the same, which is nice. And then the functionality of adding borders is basically these two functions. Of course, because we changed the size of the board to have more tiles, we had to change the size in here doing the setup. And we also had to redo the math. So now it's 12 times 26 times 2. And is that it? I believe in terms of the whole thing. Like an overview. I didn't go into too much detail. Oh, yes. So final piece, we add resetting, as I showed you before, and we also add the speed management. So before, this function was called like I don't know, define delay or define speed. I don't remember. And this is being used in the management of this, right? So we are doing that if that calls the next method, or it's going to do that or not, right? And before this was returned the same value, which it was 50, I believe. But now we are doing some sort of logic. So if you are level 10, it's going to be 35, 20, 10, 5, and so on and so forth. And if it's any value like in between those, it's going to maintain the current one. Um, so that's actually important. That's actually important. And um, a small detail that I think is actually important to mention. We had a problem before, which is that if you press a key, there's where the perception of speed from the user was really bad, right? Because of this delay. And then the solution that we did at the time was to add drawing at the detection of a movement. Nathan suggested to not do that, and you just detect that you want to have a, you're just going to apply the delay in two possible cases, which is that you don't press anything, so the piece is falling down naturally, or the game is not paused, right? Because in either other case, you're gonna, instead of doing this if thing, which actually adds the perception of slowliness and it like corrects the speed or so on, we're gonna call the next method immediately. And what that does, that we'll call, oops, that we'll call the main game loop, which is this, and this has drawing in it, right? So we are immediately drawing, so to speak. So this also solved the problem as well. Okay, so I believe it's time. I believe it's time. So I hope because this is the kind of the demonstration, this doesn't just blow up just because I wanted to show it working, and I'm gonna have to pause the recording and fix it wherever is broken, and then go back and shoot it again. Let's see. Okay, so that's pretty much it in terms of like, I'm pressing space right now to have the insta plays, which is really nice. Let's suppose that a piece is in the middle of the board and I press W. I save that piece, right? So now I'm continue playing the game. Oh, I want that piece back. I just press W again, so I have the same square that I saved it before. And again, when you grab from stored, yeah, it's gonna appear on top of like on the top part of the boards, so to speak. So level is working. The game is going faster as you level up, and do scores is also working. Things like that are working. The only thing that we are missing is sort of the having the visuals. Like, you need to know the controls beforehand. You need to you need to you don't know the score. You don't know which level you are. And all of that stuff. You don't know which piece you have stored, and things like that. So this is and adding music as well. This is actually another thing that we still don't have from the porting the game to this new game engine. But we are definitely getting there. But everything aside from that is working. So another thing that we decided to do is to make a roadmap, which is I promise, the final thing that I'm going to mention today. So the previous version of Letris, which is before Commander really joined, and we started like searching for game engines and so on, that was Letris 1.0, and that was basically like implement the game logic for the 2D version and add the visualization in the terminal. Which, as a if anybody watched that version like almost a year ago, that was really like overwhelming, because it was really hard to make something like graphically work. And then currently we are working on the version 2.0 of Letris. And in terms of the to-dos that we have left, is basically to add music to the game and then the visualization of stuff. So next piece that will fall, what is the start piece, what are the controls, which level I am, what is my score. Oh, I have controls here twice. And we also should have an indication that the game ended, right? Because I didn't demonstrate it previously, but the game ends and everything stops, but you don't know that. And then we already kind of settling on having two next like future plans for Letris, if you have the energy and the enthusiasm to do it, which is to, in Letris 3.0 we're going to add different game modes, so like a differentiation between classic and with swap and so on, and a menu in which and with like configuration, so you can change the delay configuration. So if you want to level 10 to go faster, you can do that. You can pick which game mode you want to play. You can change the music, because we have at least two versions of the Tetris song that we want to have in this game. And then the final piece would actually make the Letris into the original idea, which is to make Letris with written in this way, which means that we would have a 3D version in terms only in terms of visualization, not game mechanics, but only visualization, and you would be able to pick that visualization in the menu as well. And then I don't know how many years from now, but Letris 4.0 would involve adding multiplayer to the game, so like adding networking capabilities and like communication across different computers via the network. That would be cool to have, and that would be a mode in the game. So again, reutilizing the menu, and finally adding a 3D game mode to the game. So this is a little bit, people don't know this, but there are versions of Tetris that are graded in 2 dimensions. And we would start by having a 3D version. I believe this is like the Game Boy had it or something. I don't remember. Mageta mentioned to me quite some time ago, and he even asked me if he mentioned to me yesterday. He asked, "Did I mention to you that like Tetris has like a 3D version?" Yeah, yeah, yeah. So that's pretty much it. So this was 36 minutes. I'm so sorry, but we changed quite a bit of the game. Things are better. Things are better to read. There are some comments. We need to make use the describe in the functions to like have proper documentation. We need to get around adding sound to this to the game and visualization of stuff. That would make a tag 2.0 to the game, and then well, we go from there. We decide to do what to do from there. That's pretty much it. Thank you.